unsupervised, classification, regression, clustering, anything is fine.
Hello, sir.
Yes, yes. So you can use the chat box in Zoom, and you can write your responses there. So I would like if you could make it more interactive. So when I'll be talking, I would also be asking questions. So all of you can write your responses in the chat box so that I'll know that whatever I'm talking about is getting understood by people.
Yes, sir, I had this one question.
Sure.
So I am basically from a web developing background, totally.
Got it.
Like I am a mean stack developer and hoping for MERN stack. I'm learning React and all those stuff. And I
Got
also wanted to learn data science where I can learn machine learning, do some algorithm and make some bots out of it, something like it. So
Okay.
I wanted to know how difficult it is for a person who is from a web developing background to switch to a data like machine learning background totally.
Okay. Okay. Good question. I think we'll take it up at a later point. Today's session is more focused on testing and scaling and monitoring of machine learning systems. So we'll try to focus on that. Okay, guys. So excellent. So what I'll do is I'll begin with some of the material I had prepared for you. And as we'll talk, please feel free to write your responses in the chat box as well. So is my screen visible to everyone?
Yes, sir.
Okay, awesome. So let's talk about what is the meaning of model testing, right? So whether you're from an IT background or even otherwise, I think all of us understand what testing implies, right? So when we come to a data science context, right? Uh, when we talk about model testing, how does a typical life cycle work like, right? So what you do is, you build your model in Jupyter Notebook, right? And now you are supposed to take it to a production environment, right? Or to a production system, right? But are you sure that there weren't any mistakes which were made when you moved from the research environment to the production system, right? And if there are, how can you control the risk before you deploy, right? There are many tests like machine learning specific unit tests, integration tests, differential tests, right? That can help you minimize the risk. Similarly, how many of you would relate to what we call as monitoring, right? So while there is one term that is testing, there is another very important term which we call as monitoring, right? So what is model monitoring, right? So once you've deployed your model to production, right? Now what, right? How is it working as you expect it to work? How do you know, right? So that's where monitoring becomes very important, right? So by monitoring models, you can check for any unexpected changes in the behavior of the system. Hmm? For example, is the incoming data changing, right? Is the pattern of the incoming data changing? Is the model quality changing, right? Or are any of the system operations changing, right? So when we think about data science, right, we think about how to build machine learning models, which algorithm will be more predictive, how to engineer our features, and which variables to use to make the models more accurate. However, how we are going to actually test and monitor these models in a production system is often neglected, right? And only when we can effectively monitor our production models can we really determine if they are actually performing as we had expected. Okay, makes sense? Is everyone with me till now?
Yes, sir.
Yes, sir.
Okay, okay, awesome, awesome. So, this is a very popular plot, which maybe some of you might have seen, but there's a software consultancy firm called ThoughtWorks. And, they published this very useful diagram some time back, right? I've shared the link as well. Now, this useful diagram describes to us the steps in a machine learning system lifecycle after building our model. So those models that make it through evaluation and experimentation are then productionized, right? And once they are productionized, and once the productionization is complete, there is a testing phase, right? And once that testing is completed, then we move on to deployment. Got it? Now, monitoring also ensures at the end that the model continues to perform as we expect, right? So If you look at this entire stage, right? So when people begin working as data scientists, they typically focus on the first or second stage, right? But when they actually start moving in an industry environment, the third, fourth, and fifth stage start becoming very, very important, right? And there is significant complexity to this entire life cycle. The point to highlight is how it is a continuous feedback loop. Hmm? So depending on how, let's say, customers are reacting to our deployed models, which we detect through our monitoring, we build new models in response to this, right? Perhaps with newly acquired data from production. And so the cycle continues, right? For instance, you deploy the application, you think of any application, let's say even a B2C application like a food ordering app or an e-commerce app or a healthcare app, any app, right? So once it's deployed, the data scientists or the engineers in the background keep understanding the user behavior and keep on continuously improving the way it has been deployed, right? And to be clear, the model building and the evaluation and experimental stage generally tends to occur offline in the research environment, right? With the exception of some of the most sophisticated machine learning systems, typically this is the data scientists who are working in the Jupyter notebooks, which is the left hand side, the first and second stages. But once we reach the stage of production using the model, this tends to be machine learning engineers, right, who take the code from the data scientists and convert this so that it works with the production system, right? So essentially, from the first and second stage, it gets handed over to machine learning engineers. Now, this may many a times involve even rewriting into a different language, integrating with existing APIs, accommodating legacy requirements, or a host of other possibilities, right? So some of you who might have had past work experience or who might have worked on this earlier would be able to appreciate, right? So while you have a research environment or a POC building environment in which you do all the experimentation, you then move on. So once it moves to a production stage, it actually gets handed over to machine learning engineers. Everyone with me till now? Can I get a yes or a no?
Yes, sir.
Okay, superb. So, before we go ahead, I'll talk about a very, very phenomenal paper which I'll suggest all of you to read about, right? And this paper was written by Scully and his team of researchers in 2015, right? And I think this was one of the very phenomenal papers which, acts like a guiding light to many data scientists all over. So let me talk a little more about what we are trying to highlight here, right? So while today's talk, we'll talk about testing and monitoring, but as soon as we start talking about machine learning in the production environment, we have to start thinking of entire systems, right? Not just a Jupyter notebook, but you got to think of the entire system. So the diagram which you see on this slide helps to explain that point. Okay. So as you can see from the diagram, that in a typical machine learning system, the machine learning code is a very, very small component amongst others, right? So the small component that you see in black, right, in the center of the uh, slide here, right? That's the, if you look at in terms of volume, that's the size typically of a machine learning code, right? And all the other blocks that you see around are very critical to ensure that the machine learning code that you've deployed works the way it is expected to, right? Now, all these codes that you see around, right? For example, you are looking at feature extraction and monitoring and underlying infrastructure, right? So all these are multiple large components that are there. So the key point from the paper, when if you go back and read about it, is that machine learning systems are hard, right? Compared to a typical software system or a typical web-based system, machine learning systems are harder, right? So why am I saying it's harder? It's harder because they have all the pitfalls, or they are, or they can have all the pitfalls of traditional software systems, but with additional challenges such as data dependencies, model errors, right? And many of these can't be caught with traditional tests or traditional monitoring. and expertise requirements that span data science through the devils. This is why specialized testing and specialized machine learning monitoring is very necessary in order to maintain these kinds of systems. So let's consider this diagram in a little more for the purposes of testing and monitoring. So we are particularly interested, let's say, in data collection in the production context, right? Not the initial exploratory research, but rather the files, scripts, the database joins, and API calls for all to prepare data for the model in the production system. Then you also see a feature extraction code, right, where the feature engineering logic is contained, and a frequent place where subtle bugs can arise. Then there is a data verification module, which we also call as the data validation code, right? And this is where we capture our experimentation about incoming data and where input sanitization techniques, for example, removing missing values or beyond the allowed values are done, right? And our system configuration, right, where we set the hyperparameters for our model as well as other key things such as references about which model to use, which version of the system to use, right, and a host of other potential settings with major implications. Now, each of these components can have a profound impact on our system behavior before they get deployed to production. We want to test them once they are in production. We want to monitor each of them, and we also want to monitor our serving infrastructure. Is this slide clear? Am I able to emphasize the importance of each of these aspects?
Yes, sir.
Can I get a yes or a no in the chat box from everyone?
Yes.
Yes, sir.
Okay, okay, great. So now let's move to more specifics, right? So, in the previous slide, I was talking about why testing is important and how there are so many modules in a production scale machine learning system. Now we'll get into more details, right? So we'll talk about specific tests in this slide and why do we have these tests, right? And why are these tests really required? So let's just jump right in. But before that, I would also like to give a mention of the paper that I'm referring to here, right? So you might see it in the bottom right, and I'll strongly suggest all of you to take a look at this paper. Once you are through with the initial level of courses in your journey at ages. Okay, so let's go into more details into this slide, right? So as I said earlier, no, machine learning systems differ from traditional software systems because the behavior of machine learning systems is not entirely specified in the code, right? But it's also learned from the data which is being used. Therefore, while most software can rely on traditional tests, right, the traditional unit test and differential test and integration tests, machine learning pipelines require machine learning centric tests at various levels, right? So that's not to say that non-machine learning parts of our system don't need testing and monitoring, right? We will have all these standard tests, but at the same time, we'll have more advanced tests as well. So if you look at the top left, right, the three tests, which is data tests and ML infrastructure tests and model tests, right? So these three are machine learning specific tests. And if you look at the right hand side, which is data monitoring and prediction monitoring, right? These are tests or these are monitoring stages which are very critical during the shadow deployment and afterwards. Everyone with me till here?
Yes, sir.
Okay, great. And the classical tests, right, which some of you who are from a web development background would realize, right? The unit tests, the integration tests, and the system monitoring tests. These are all tests which are also known as the classical system tests. Got it? Can anyone explain what shadow deployment means? Okay, no worries. We'll cover that in a future slide. Okay, so this is what we were talking about in one of the previous slides, right? So you have the research environment, which a lot of you would be doing in Jupyter. Are there other IDEs which some of you use? How many of you use Spider, or how many of you use
So
PyCharm?
Spider, Python, Work Lab, everything we'll use.
Sorry,
So Spider mainly.
mostly Spider. How many of you use Jupyter?
I use Jupyter.
Yes, I use also Jupyter.
Jupyter.
Okay, okay, great, great. So guys, so most of the work that you do in Jupyter, right, that is what we call as the research environment, right? And that is where you test different algorithms, you test different configurations, hyperparameters, and so on, right? But the next stage is, what we call as the development environment, in which you run all the tests, right? For example, you run the unit tests, integration tests, differential tests, load tests, benchmark tests, and so on, right? And finally, when you move to production, right, that's where you again run a lot of monitoring and observability tracking, right? So things like logging, tracing, alerting, checking for skews, doing profiling, a lot of those things are done in the production environment. So if some of you are from a web development or a software engineering background, how many of you maintained an application in production?
So can you
Okay,
repeat the question?
I know I was asking if any of you are from a software engineering background.
So me.
So have you maintained or worked on a software application in production?
Yes, I did.
Okay, okay, great. So you might be able to relate to some of the work that you would have done, right? In terms of
Yes, yes,
monitoring and logging and tracing, etc.
yes,
Right?
yes, yes.
Okay,
Yes.
okay, great. Okay, so again, let's talk about testing, right? And when we talk about testing as a stage in development, what I've observed is that there are some people who sort of like it a lot because they feel like being detectives, right? And then there are some people who I've observed, which perceive this as being boring, right? But either ways, whether you find this very exciting or boring, it's very, very important, right? And why is it important? Can anyone, in a single sentence talk about it? Why do you think testing is important?
To sir understand how our model get trained from the training data.
Okay, anyone else? Why do you think testing is important for any
What are the
application, right? Whether
consequences?
machine learning, non-machine learning, why is it important?
What are the consequences if something fails? Or
Got it.
are we fulfilling every parameter that are required to be filled?
Okay, okay, great, fine. So, are all tests equally important, or are there some tests which are like mission critical, which are like must-have tests, and there are other kinds of tests which are, let's say, good to have tests, but not very critical. So,
Yeah,
can
there
anyone
will
give an
be some
example?
critical and some non-critical tests
Got
to be
it. So
done.
from your experience, excellent. So, from your experience, can you give an example of, let's say, a test which is mission critical and a test which is a good to have test but not very important?
Sir, like in deep learning projects, we are working for any medical projects type things.
Okay.
So testing matters a lot, and for some projects like which is not much critical, so testing does not matter a lot, I think.
Fair, fair. Okay, okay, awesome. So see, as many of you said, right, testing is important because it helps us to establish that the system that we've developed is working the way it was supposed to work, right? and no application today that we build, right, remains static. Every application in industry goes through changes, right? And the real value of testing is realized when systems are changing, when you're adding more features, when you're running patches, when you're upgrading your application for any reason, right? That's when the real value of testing comes, right? For example, if you have a hard timeline that, hey, in 3 weeks, in 2 weeks, you're supposed to deliver a new feature, right? That's when testing becomes very important. That's where standardized testing becomes very important. And why is it important? Because it helps you as a developer to have more confidence in your system, right? It reduces the uncertainty when analyzing a change to the system, right? In a way, if you've tested your system well, you'll get a good night's sleep, right? You'll not be worried about, hey, we made all these changes, and will there be any problem, right? It makes your system very reliable, right? You'll be very confident that, hey, we've made these changes, we've tested them well, and we'll not have any problems when we'll deploy them in production and we'll monitor them. Okay. Awesome. So we'll move to the next slide. So when we talk about testing and monitoring, right? So there are, we would say, two stages, right? One is before the deployment and one is after deployment. Fine. So when we say before deployment, it implies this particular slide, right? Wherein we are in the research phase or in the in the development environment, right, where we haven't really launched into production, right? That's the pre deployment stage, right? And then what you see on the right hand side is what we call as the post production stage, right? And the kind of tests and the kind of monitoring we do in pre and post varies, right? So let's now look at some of the key testing principles for machine learning in the pre-deployment phase, right? When you're still in your research environment, when you're still experimenting, when you're conducting your unit tests or differential tests and so on, right? So we'll review why in this slide we'll talk about why testing machine learning systems is hard, right? And then we'll also explore the testing principles and strategies that we can use in our system, right? All right. So let's start to consider what makes a machine learning system difficult to test, right, than a traditional software system. Now, one key element that controls the behavior of the system is the data, right? And the other element that controls the behavior of the system is the, so there are two elements, right, we spoke about. So one is the data and the other is the model. Got it? And the third element, and a very important one, is the code. So there is data, there is model, and there is the code. There are three elements, right? In a traditional software system, there is only code, right? You don't have a model and you don't have data, right? And in a machine learning system, you've got the model and the data as well. Make sense, everyone? This is very, very important to understand why machine learning systems tend to be more complex, because they have the data and the model complexity in addition to the code complexity. Make sense, everyone? Can I get a yes or a no?
Yes, sir.
Okay.
Yes, sir.
Great. Awesome. Awesome. So another important aspect is that the traditional software systems are constructed deductively, right? And what we mean by deductively is that, we write down the rules that govern the behavior of the system as the program code. However, with machine learning systems, these rules are often inferred from training data, which means that they are generated inductively as a result, right? So it's again a very stark difference, right? So people, who've done software engineering earlier, they would realize that the way they do testing is through a deduction methodology, right? But when you'll do this course and at the end of it, you'll realize that the testing here is done in a more inductive way rather than in the typical deductive way. right? So the machine learning systems, as we said, require extensive testing and monitoring because the rules governing the system behavior are less clearly defined, while traditional software systems can rely on unit tests and integration tests of the code. Machine learning systems require additional tests at various levels as ML-centric unit tests and ML-centric integration tests that you see in the slide. Now, many of the ML-centric tests are not obvious and outside a typical engineer or data scientist sphere of knowledge. While software testing is well studied, and nowadays machine learning is increasingly getting well studied at the intersection of between the two, right? And the intersection between these two is now also getting more and well explored, right? So while I shared two papers today, which I'll suggest everyone to go back and read about, you can also search more online, and there are more recent papers that have been published in this topic. Okay, now I think we've talked enough of why it is difficult to test machine learning systems, right? Now, let's get into the specifics of how we should go about testing these systems prior to deployment. So I shared the paper earlier, I'll send the link as well. So this paper is called the Machine Learning Test Score, a rubric for machine learning production readiness and technical debt reduction, right? Now, this paper effectively presents a checklist of tests, procedures, monitoring that you should have in order to conduct production machine learning. Now, we'll cover some of those in the next few minutes, right? And for more details, you can go and refer that paper. Okay, now let's talk about all the 6 pointers that you see in the slide, right? Now, one important aspect is a schema for features. So do all of you understand what features are?
Yes, sir.
Yes, sir.
Yes, no, right? So these are the, is this independent or dependent variable?
Independent, sir.
Dependent.
Okay, awesome, right? So one important aspect here is having a schema for features, right? So it's useful to encode all the intuitions about the data in a schema, right? So that they can be automatically checked, right? So for example, if you have 100 features, right? So each of those features will have certain lower bounds, upper bounds, certain distributions, etc., right? So it's always useful to have some sort of schema for each of the features. The other is the model specification tests. So some of you might have heard of things called the config file, right, where you write all the configurations. Similarly, in machine learning, we have a model config file, right? And this key model config file, for example, contains hyperparameters, right, that are being used, and they also they undergo both a code review and have unit tests also in some cases. Now, this can be to flag unexpected value changes or choices, and we can, in the paper or even otherwise, look at some specific examples. Another important aspect is all input feature code is to be tested. So feature creation code or feature engineering code may appear very simple, right, to not need unit tests. But this code is crucial for correct behavior, and so its continued quality is very important. Another aspect is validating the model quality before serving. So before we push the model to a model upgrade to production, we need to test for 2 types of degradations in quality, right? And the 2 types are, one is what we call as sudden degradation, and the other is what we call as the slow degradation, right? And both these degradations happen in, one or both, or sometimes none, right? But the systems are always susceptible to these degradations. One very important aspect to check, and that's a foundational step, that's a very fundamental step, is to ensure that the model training is reproducible. Any idea what that means, that the model training is reproducible?
If we take any kind of test data, it works in a similar manner for that data as well. That's reproducibility.
Okay, okay. Anyone else? That's a good answer. Okay, so see, ideally, what I'll talk about this in a little more detail about the model training being reproducible, right? So ideally, training twice on the same data should produce two identical models, right? So deterministic training dramatically simplifies reasoning about the whole system and can really aid auditability and debugging to avoid any non-reproducible training. So what you should do, you should look for any sources of non-determinism in your code, such as failing to set a random seed, right, or not ensuring that the keys are sorted in dictionary or the response JSONs during the training, and certain types of optimization algorithms, right? And this is not trivial, right? Many a times, some people miss this, right? So it's important to ensure that you have a checklist in your training uh, pipeline that to ensure that you've made it mandatory for yourself and your team that all these checks for model reproducibility have been made correctly, right? Okay. Another important aspect is integration testing, right? So in one of the slides earlier, we saw about how the complete machine learning pipeline is uh, comprises so many components, right? And if we talk about this pipeline, it consists of assembling the training data feature generation model, training, model verification, deployment, serving system, right? So although a single engineering team may be focused on a small part of the process, each stage can introduce errors that may affect the subsequent stages. This means that there must be a fully automated test that runs regularly and exercises the entire pipeline. Cool. Okay, great. I think that has been a lot of information, and I hope I was able to emphasize this point to all of you very well. Okay, so now let's move to the next point. Sorry. Hang on, I think. Okay, no worries. So now let's move to the next point, which is monitoring after deployment, right? So the previous slide which we saw spoke all about pre-deployment, right? So defining all the schemas, unit tests, integration tests, differential tests, and so on. Now we'll talk about post deployment. But before I go there, has anyone heard of Python technologies like or Python libraries like PyTests and unit tests? Okay, if you haven't, you can make a note of that because they are some of the industry standard libraries that are used. So when you will in future work on any of the capstone projects, you can utilize those libraries, right? So many of the things I spoke about some time back are very well done or very easily done if you use the functions and other features that are available in these libraries, right? So one is PyTest and the other is unit test. So PyTest is more modern and it has many more advantages compared to unit tests. Cool. So if you check the site of PyTest or you search about PyTest online, you will get the differences between PyTest library and the unit test library. Okay, so now let's move to monitoring after deployment. Okay, so why do you think, if we've done so much of testing in pre-deployment, why do you think post-deployment monitoring is important? Can you give some reasons why we still want to test and monitor, why we still want to monitor and observe post deployment?
So that for the industrial data, like for the real data also, if our model is working fine or not, we can check.
Okay, okay. Anyone else?
So for the deployment, like there are multiple levels to which you're adding. You're not just using the same platform that you're using for testing. And while when you deploy it, there are, let's say, another one or more, two more platforms. You need to make sure that your model is performing the same and the flow is maintained while working on those platforms as well.
Okay, okay.
Also, we might need to tweak some parameters basis the data, input data.
Mm-hmm, mm-hmm. Okay, okay. All good reasons. So let me try to classify the reasons which some of you spoke about into three buckets. Right? Bucket one is many a times what happens is the model, the variable values change. Right? So what you had observed in the training set, right, could be different from what you observe in production. Right? The second one is, there are changes in the variable distributions themselves, right? And why do these variable distributions change? Right? For many reasons. For example, the populations change, people change behaviors, right? And these changes happen many a times because of natural reasons also. At the same time, if you look at this in another way, businesses may change their direction, right? Now they may start accepting new population sectors, or now they may launch into new geographies, or they may start targeting different target groups, right? Which they were not targeting earlier. Uh, Many a times the feature definitions also change, right? For example, let's say the legal drinking age was something else some time back, and today it's become something else, and 5 years down the line, it may be something else, right? And this is also different, let's say, over time and also across various geographies, right? And so there is a lot of variability in these things, right? Similarly, if we look at certain industries, right? For example, if we look at cars, right, or automobiles. So, what do you think is one of the biggest changes that's happening these days when we look at automobiles?
The shift to
From IC
electric.
engine to electric engine.
Absolutely, right? So now gradually there is a lot of emphasis globally as well as in India to move to electric cars, right? So now suddenly our feature sets will change, right? So let's say if you will pick up an older data set of cars, you'll have different features about the technical specifications of a car. But if you take an electric car, you'll have different technical specifications, right? So whatever predictions you were making with the cars earlier cannot be used now, right? You'll have to completely change the data set, right? So this could be pricing, this could be demand, this could be the players in the market, and so many other things, right? So similarly, we can talk about each and every industry and how these things change, or how the variable distribution changes and sometimes becomes stale if we don't move our data sets and keep training them, right? Similarly, many a times the performance of the models also change, right? So the same way, like we spoke about, the variable distributions today might be different compared to the variable distribution yesterday. Similarly, the performance of the model might be different today compared to yesterday, right? But if we have the ground truth available or the distribution of the predictions, how often to test the model depends on the volume of the data that we are getting, right? So one question which I often get asked is, how often should I retrain my model, right? Should I retrain it once every week or once every month, or how often should I monitor the performance of the model, right? So it again depends, right? So for example, if your model is producing 500 predictions every day, right, you might want to implement the tests daily, right? But if let's say the model is producing 500 predictions in every second, right? You might want to run the tests even more frequently, right? As the data is so volatile and is changing so rapidly. Got it? Okay. Now, so during the shadow deployment, we run different tests to determine if the data in the live environment was representative of the data in the training environment. And in particular, we do all these variable value checks, performance changes, data distribution changes, blah, 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 right? At the same time, it's also very important to check the computational performance of your application, right? So on the left-hand side, what you see is monitor model predictions, right? Which is more around the accuracy of the models themselves or the reliability of the model themselves. But equally important, or in fact, sometimes more important, is the computational performance, right? See, the system has to work and it has to work at good speed, right? So can anyone talk about the top 3 apps that they use on their phone?
LinkedIn, Instagram, and bus.
Okay, anyone else? What are your top 3 apps on your phone? No one uses apps.
Instagram, Twitter, and Bro.
Okay, so how much time does it take for your app to load when you open it?
Like 1 second or two.
1 second? How much time?
Microseconds.
Sorry?
In microseconds, like
In,
0.2
in,
something.
got it, got it. Awesome. So just imagine if some of your favorite apps that you use don't load in a microsecond or a second, but they take a minute to load. Would you still use them?
No, why we
No,
will
right?
waste our time?
Absolutely, absolutely, right. So similarly, on the same lines, if you are building the application, right, for a production gate system serving latency is very important, right? Even though you might be running a lot of machine learning layers, a lot of deep learning layers, but it has to run real fast. I mean, all these apps that you're talking about have recommendations, whether you use Instagram or LinkedIn or Swiggy or Zomato or any app you talk about, they all have recommendations, right? But just imagine if these recommendations took minutes to run, right? We won't use them, right? And that's the reason why it's very important to ensure that while you maintain the accuracy, but you also ensure that the system serving latency is is as low as possible, right? Having said that, there's also a fine line here, because in certain applications, let's say in certain very critical applications, it's very important to ensure that it's very important to understand that, hey, it's okay if it takes more time, but I need my system with as high accuracy as possible. Can any one of you give an example of that? Where the speed is not important, but the accuracy is more important.
Yeah. Any medical
In
information.
medical field, like for cancer detection or anything.
Okay, that's a great example. Anyone else? Okay, well said, right? So, some of the applications which are very, very critical in nature, you're like, okay, we can wait for some more time, but the results that we get should be of has as high accuracy as possible, right? It's not like, I want the lab result in a few microseconds. It's okay if it takes some more time, but it has to come with as high accuracy as possible, right? So as a data scientist, you need to be cognizant of the environment you're working in, of who your customers are, or what domain you are in, when it comes to the fine balance between the model accuracy and the computational performance. Now, I'll share a couple of technologies which are used to monitor these, right? So one of the popular technologies is what we call as ELK stack, which is Elastic, Logstash, and Kibana, right? That's a very popular stack, right? The which is used for monitoring. The other popular stack for monitoring model metrics is what they call as Prometheus and Grafana stack, right? So we won't have time in today's context to go through them, but I will recommend everyone to go take a look or maybe do some tutorials. Maybe they are already covered in your course, which you are doing, but Prometheus Grafana is one very amazing stack for post-production monitoring, and the other one for logs is the ELK stack, right, which is Elastic, Logstash, and Kibana, right? And they are used in many production-grade industry systems as well. Okay, so I think with that, I come to the end of what I thought I'll present today, but I am more than happy to take up any questions which you may have. I'll stop sharing my screen.
Yeah, yes, sir. As a fresher for coming in data science field, we
Yeah.
need to know end-to-end implementations of any projects like things, or we have a knowledge of machine learning or statistics is enough for us for coming in data science field as a fresher.
Got it. No, that's a great question. See, data science, machine learning itself is a very diverse field, right? So, and it takes time to master or to become an expert in each of the stages in the development life cycle, right? Or the industry popular term is full stack data scientist,
Yes.
right? Who can do everything from end to end. So, of course, when you start, you will focus on one area, right? So as a fresher, you should focus. You should know the nuances of the end to end. You should appreciate you should be able to appreciate the complexities end to end.
Okay.
But yes, when you'll start mastering, you'll have to start mastering step by step,
Okay, sir.
right? Otherwise, it will be a lot for you to consume or for you to absorb. Right? That's my suggestion. But there are exceptions on both the sides. There are people I know, who are full stack data scientists and they are experts in everything. There are some people who focus in something very, very specific, right?
Like
Either
sir,
is stage, yeah.
like so when you are interviewer and you are interviewing a fresher for data scientist, so what you want from the students, that's I need to know.
Okay. So see, when we hire freshers, one aspect we look at is the clarity in the concepts,
Okay.
right? The ability to solve problem. Let's say, I mean, if there are 50 different algorithms, right?
Okay.
You need not know all the 50, but if you know 10, you should know them well.
Okay, sir. Thank you, sir. Thank you so much.
Got it? Because the domain itself is very, very. I mean, it's evolving very fast, right? If you follow any of the research papers, you'll realize every 3 months, 6 months, there's something new and something very revolutionary that gets released,
Yes, yes, sir.
right? So even in the industry, you'll have to keep evolving yourself. You'll have to keep upgrading and keep learning, right?
Okay,
So
sir.
the journey never ends. It all.
Yes, sir, it does.
Yeah.
Thank you so much, sir.
Okay. Okay. I hope that helps. Any more questions, anyone?
So, Mohit here.
Yes, Mohit.
Like for a genuine, let's say, a project, if some company is pursuing, if we say it
Not
is
able
being
to
done
hear.
into one,
A lot of background noise. You can write your question in the chat box, Mohit, or if you can move to a low
So
noise
is this
environment.
better?
Yeah, this is better.
So I was wondering, like, if for a company that's pursuing a project, like to do it end to end, how long does it generally take? Does it depend on the size of the project? Does it depend on the domain? Does it depend on like what sort of audience you're targeting?
Yes,
How does
yes,
it vary?
absolutely. I think these are all critical components. So, an end-to-end project, again, it depends on the complexity. So in the industry, I've seen projects which people take even a year to complete, or sometimes even more than that, right? And then there are certain projects which can be done within a month as well, right? And the time depends on multiple things. One is the complexity, the second is the data availability, third is the skill of the people who are working and the experience of the people who are working on it. So it depends on a lot of factors, but the time duration can vary depending on how complex the problem is and which domain also you are working in, right? Whether you're working in healthcare or retail or e-commerce or supply chain, depends.
So the validation part, like which would be very important, I believe, to any project. So would you say that it takes up around at least 25 to 40% of the time? Like, would you say that would be the case?
Yes, in fact, it can take even more. If you are working on a production grade system, right? The validation testing can take even more time than that.
All right. Thank you so
Yeah,
much.
yeah, yeah. Okay.
Any more questions? So that was a superb session, sir. And as a students, the focus is actually on learning the basics first, right? So, and then doing the projects. The focus is never on the deployment and testing and these things, right? So these are the standards that we learn today from you, sir. And this is something like our students can do while doing their portfolio as well as their capstone projects. And this will be add-on for you guys, because the people, those who are just your competitors, will be knowing like the basic knowledge of it, of ML and all. But just imagine that you are able to answer, like you are saying that you have done into your project, like you have deployed it and you have tested it and you have monitored it, so you are doing beyond the normal crowd. So I again urge my students to, like, whatever you have learned today, to implement into your portfolio as well as your capstone projects. So we learn a lot from you today about these technologies that are being used into industry. Thank you, thanks a lot for your valuable time and information that you have provided. And like with this,
Amazing, amazing. I hope this session was helpful for everyone, and I had a
of
great
course,
time
really helpful.
speaking to all of you.
Yes, yes, sir. So with this, I conclude the session. Thank you, sir, once again. Thank you, everyone.
Okay, have a good evening, everyone. Bye bye. Take care. Have a good
Thank you, sir.
weekend.
Bye, sir.
Thank you,
Thank
sir.
you, sir.
Bye, everyone. Thank you.
Bye, sir.